Hello, and welcome to this demonstration video which accompanies our Better Heating campaign. My name is Mark Boccetti and I am the Technical Advisor for Spirotech in the UK. We are all very reliant on our heating systems for our hot water and heating demands. So maintaining the efficiency and reliability of these systems is very important. This is what our Better Heating campaign is all about. At Spirotech, we believe that the most important component in your system is the water. If we maintain the quality of the water, we give that system every opportunity to work at its design efficiency. But if we allow the quality of that water to deteriorate, then the entire system becomes less efficient. We describe water as the universal solvent and is used in industries throughout the world. This is because water has some fantastic properties. And one of water's abilities is to absorb gases. Now, the amount of gas that water will absorb, in this case air, is dependent on temperature, but it's also dependent on the partial pressure of that gas in contact with water. We know that air contains oxygen, and it's the dissolved oxygen within the water from the absorbed air that promotes corrosion. This electrochemical reaction is the breaking down of the system components. This produces the rust and magnetite that we see in systems, and we know that this can have a costly effect. Higher running costs, frequent failures. So dissolved oxygen will have a detrimental effect on the system. But it's not just the dissolved gases that we need to consider. Through an increase in temperature or a decrease in pressure, dissolved gases come out of solution. They are liberated. It's these liberated microbubbles that also have a negative effect on the system. Noisy pipework, noisy pumps, frequent bleeding of radiators, reduced heat output from radiators, and of course, reduced flow through system pipework. The solution to these liberated gases is the deaerator. As the heat engine in the boiler starts to heat the system water, tiny microbubbles will start to accumulate on the walls of these heat exchangers. It's the system flow flowing through the heat exchanger that carries these microbubbles from the heat exchanger into the system. The deaerator is designed to remove the liberated microbubbles from system flow. So this is our demonstration rig. It's a fantastic visual aid which not only shows the liberation of gases, but also shows how effective our technology is, the SpiroTube. It's in all our physical products, and its construction is pretty simple. Copper wire on copper fins on copper pipe, and they are all fused together using solder. So this demonstration rig replicates a central heating system. The rig is currently pressurized to run about 1.3 bar gauge pressure. I'm now going to decrease the pressure from 1.3 bar down to 0. And we should see the gases being liberated. Bearing in mind that this is to replicate the heating of the water in your boiler at home. Remember, it's an increase in temperature or a decrease in pressure that will liberate the gases. Before I decrease the pressure, please take note of how still the water looks and how quiet the system is, even though the pump is running at its maximum. This is because it's running through the deaerator. And this is what we would like to achieve on every system. One thing I would like to mention though is the AAV, the automatic air vent. AAVs are near enough redundant when there is movement of water. It's not that this isn't a high quality AAV, it is. This replicates one of our own AAVs. And it's manufactured to a very high quality, which is why it comes with a 20-year guarantee. But the application is not to remove free air or microbubbles from system flow. AAVs are used to remove free air when we are filling up a system. And of course they are used to allow air to be drawn into the system when we are draining down the system to release the water. So let's decrease the pressure. Remember, the release of gases is slow and it's in the form of microbubbles. Now the average system contains between 80 and 100 litres of water. In this demonstration rig, I have around about 1.5 litres of water in the outer circuit, but you'll still be amazed at how much gas can be liberated from such a small volume of water. But the most impressive thing is that for the average system, the cost of the most important component, the water, it costs less than £1. Less than £1 for the most important component. That's nothing. Now, if we maintain the quality of the water, we give the system every opportunity to remain efficient. We can definitely hear the change in sound now. And we can definitely see the gases running through the pipework. Now let's run this through the deaerator. Notice how much quieter it is becoming. And if we allowed this to run for around about 10 minutes, the water would look completely still, like it did at the start of the video. That's how effective the SpiroTube or the deaerator can be. But now let me show you an exaggerated scenario, because we know that air within pipework does restrict flow. We can see the water going fast, slow, fast, slow, fast, slow. And this is because, of course, as I mentioned before, the gases are creating a restriction in flow. Now, if a boiler was attached to this demonstration rig, the boiler would need to shut down because the heat would not be able to escape the heat exchanger quick enough. Now, if we run this through the deaerator, in no time at all, we can regain the intended or the designed flow. I would now like to introduce some dirt so I can explain to you exactly how the separation technique works. So we take a nominal bore, say 22 mm pipework, we expand the area. By opening up the area, we reduce the speed or the velocity of the water as it enters the separation chamber. It's in this chamber or dirt chamber or separation chamber where we reduce the velocity that the SpiroTube performs its functions. The first function is to literally separate the dirt particles or the microbubbles from system flow. The second function is to counteract or reduce the turbulence. The less turbulence, the better the separation. Deaeration is based on high temperature, low pressure. And so for the inline units, these are generally fitted on the flow pipe coming out of the boiler. For dirt separation, these are generally fitted on the return pipework to the boiler to protect the most expensive component, the boiler, and of course any components thereafter. I hope that you have found this demonstration video useful. Thank you very much for your time.